There are actually several ways to evaluate limits like these. All right, you can graph the function and see where you're approaching from both sides. You can make a table and see and plug in values on both sides of 4 and see what you're approaching from both sides that way. But in these two problems, we're going to do it analytically or algebraically by plugging values in and factoring and stuff like that. So we're going to do it without graphing or without tables. We're going to find the limit as x approaches 4 of this function to start with. Now the first thing you always do when evaluating limits is to first plug the value in. Plug 4 in, see if it works. So many students forget that, and they do all this work and realize they could have just plugged it in. Here's what I mean. Ready? All we're going to do here is take the square root of 25 minus something squared. And to find the limit, you're basically just plugging 4. That's the easiest way to find any limit, and sometimes that's all you have to do. So when I plug in 4 to this function, do you notice what you're getting here? Watch this. The square root of, it's not going to be 25 minus 16. Wait, isn't that the square root of 9? Wait, isn't that simply 3? That's the answer. That is simply the answer. The limit as x approaches 4 of this function is 3. That's all you have to do. So the first thing you always want to do is just plug it in. It's easier than doing the graphing method. It's easier than drawing a table and making a table and scrunching it. Plug the value in and see if it works. Now I will tell you, most of the time your teachers aren't going to make them so this is this easy. But always check it because it just saves you so much time. There's always usually a test question and all of a sudden it's like, oh, I could have just plugged it in. No, I wasted all my time doing other stuff. So plug it in. Again, most of the time that's not the case. So let's do it when it's not just plug it in. So the second thing we do is factor and simplify fractions, then plug in the value. So let's try to factor and simplify this. All right. So what I'm going to do here is I'm going to do, okay, rewrite limit as x approaches -3. It's actually important you rewrite the word limit when you're simplifying the limits, because we want to make sure I keep the limit idea going along. What I'm going to do is I'm going to factor the top. Hopefully you notice that's called a difference of squares. Leave the bottom. Okay, so you first, the best way is factoring and then try to simplify. Do you see anything simplifying? Oh yeah, those simplify. Okay, what do I get when I do this? Okay, I now get the limit as x approaches -3 of x minus 3. Okay, now you might think, okay, I just simplified that. Do you guys understand that this and this function are exactly the same function? Something you'll learn later is this function just basically has a hole at -3. You'll catch on to that in the future in some other problems we get to, but just showing you that right now is that this function again and this function are the same exact graphs. Just this one does not have a hole. This does have a hole at -3. Interesting. So what I do now is this new function I made, since they're the same function, just a simplified version of it, I can now simply, all I do is plug that -3 in right there. So I have something minus, I put a negative, what minus 3, I put the -3 in. And what do you get? -3 minus 3 is -6. So what is the limit as x approaches -3 of this function? It's -6. So if you can, factor, simplify, then plug it in. Now, you might have wondered, well, why did he do what he did here? Because I knew it wouldn't. Why didn't I not just put -3 in? Well, let me show you why. Watch what happens. When I plug in -3, if I would have just plugged it in, that would have been -3 squared minus 9 over -3 plus 3. What do you notice here? That becomes 9 minus 9, which is 0. -3 plus 3 is 0. 0 over 0 is indeterminate form, meaning you cannot determine it because you cannot get zeros in the denominator. So this right here wouldn't have worked. I can't just plug it in. So usually when you plug it in, you get a 0 in the denominator. It means you have to try to factor and try to cancel something, reduce, then plug it in. There are other ways as well besides factoring and simplifying. There's something called rationalizing. I'm not showing it to you on this one, but there are other things you can do. Not all of the problems you have to factor and cancel. There are other methods you can do to manipulate it and then plug your value in. For instance, when you have trig functions, there's something where with sine x over x and some other situations where you can do some simplifications and you get answers with some basic trig ideas, but that's a whole other story. So the most common is to factor and cancel. So I'm showing you the most common thing. So we're basically making a new equation that we can plug the value in. We're going back to this idea. So summary, plug the value in if you can, check it. If when you plug it in, it doesn't work, which you want to check that. I knew right away it wasn't going to work, so that's why I didn't show it at first. But anyways, so we then factor, cancel, simplify to another version, then plug it in and see if it works. Find the value from there. Now again, there are other ways you might simplify. I'm not going to show it to you here. You might see it in some other examples. Good luck with these. Just be careful with limits and make sure you do the procedures I talked to you about. Good luck with them.